Okay, now let me check that these are actually adding up. Whoops. Okay, 19, 18, and 19. So that's my support low, moderate, and high grouping variable. So once I've done that, and that's really pretty much all the work you have to do, now that you've done that, you simply have to do a scatter plot where you regress symptoms onto support, categorize across the three levels. Now I'm going to use the centered variable for support, even though I'm not totally convinced you would have to, because David Howell does it that way, and I just want to compare his plot, which is doing the same thing but using the Aiken-West approach. So, because this is ultimately going to point out that really important thing that I mentioned at the beginning that we should always bear in mind. So support hassle-centered on the x-axis and symptoms on the y-axis. But I want three different regression groups. So I'm going to set markers by group. And this is going to create a scatter plot with the effect of hassles on symptoms. And this is what the scatter plot looks like. But this isn't the crux of the analysis. I just have to do one more thing. I just want to change this to white first. Okay, so now that I've got, it does demarcate it a little bit. You can see the blue are support low, support green is for moderate, and high is this beige color. But if you click on this here, it's add fit line at subgroup. So it's going to create a fit line for the three groups, which is really, like, it's great. You don't have to do this thing by hand. And what you can see is that support low, I don't know how well you can read that. Actually, it might be a little bit better if I go into here. So support low, which is the blue line, has a really strong regression effect. We can see that the r-squared linear is 0.464. So if I was to square that value, 0.464 square rooted is a correlation of 0.68. So the correlation between hassles and symptoms is 0.68 for people with low support levels. Okay, but then when you go down to moderate, the r-squared is only 0.32. So if I 0.32 square root that, the correlation drops to 0.565, and then it drops even further for high levels of support. 0.149 square rooted is 0.386. Alright, so that's what the interaction effect really is. At the crux of it, that's what an interaction effect is. It's the nature or strength of the relationship changes as a function of another variable. And in this case, the nature of the relationship between hassles and centered changes from low, moderate, high levels. In fact, what's happening is it's going lower and lower. And so if you have high levels of support, the correlation between hassles and symptoms isn't very strong because support, arguably, is acting as a buffer. And this is a great way to depict the nature of an interaction effect. Now, it doesn't look exactly the same way as the Aiken and West approach that is depicted in David Howell's textbook. And I suspect the main reason for that, and this is getting to the real important thing, is that if you look at these two pieces of observation in the scatter plot, these observations look to me like outliers. They're not even close to the other. If you look over here, this is where everyone is over here, and then there's one way out here, and there's one way out here. And that's the question, did you test for did you at least examine the data for outliers? Now, if you look at outliers in this case, and I've done an analysis looking at, I've done a separate video as to how you test for outliers. What you find is, in fact, that these two observations are in fact outliers. And when you remove these two observations from the analysis, the interaction effect disappears. It's no longer statistically significant. And we can look very quickly at the data. We just have to look at the frequency distributions at the univariate level. We can see that there are, we'll look at the histogram